In today's video, let's examine human memory system and I will mapping them into AI mechanisms. So we will gain insights into both fields. So first one is sensory memory, which corresponds to the initial encoding of the input into embeddings. And the second is short-term memory, which is aligned with the AI's context window during the processing. And the third one, which is the long-term memory, it is reflected in the AI stores knowledge within the parameters and its external databases. So understanding this parallel helps us in developing AI systems that can mimic human-like processing and enhancing the capability to interact and assist into a more natural and effective ways. Let's see a concrete example that combines human memory and AI mechanisms. The scenario is learning and recalling a new language. So in human sensory memory, you just heard a word in Spanish, gato, which means cat, right? And that sound lingers for a few seconds. And then your short-term memory is you repeat gato several times to remember it. And then your long-term memory is through practice and usage, gato, become part of your vocabulary. And implicit memory is you can recall the word gato. When you see a cat, you know, oh, it is a gato. And the implicit memory is you start to use the word gato in sentences without conscious effort. In AI systems, sensory memory is embeddings, so this AI processes the word gato, which creates an embedding which representing its meaning, and the short-term memory is the context window, which is during the translation task. This model holds gato in its context to understand and translate a whole sentences, right? And another is long-term memory, which contains the explicit memory, which is knowledge bases. So this AI stores gato within its English. Its equivalent is cat in its vocabulary databases. And another is implicit memory, which is the model's weight. So through the training on bilingual tasks, this model learns patterns of language translation. Now let's talk about bridging mechanisms between human memory and AI system. First is human sensory, which encodes information. The input is encoded into neural signal. The example is when you are reading a book that converts visual stimuli into neural activity. But the AI system that encodes information is by the raw data, which is converted into embedding. The example is the text input is tokenized, right, and embedded for processing. And the second one is humans storage and retention. So the rehearsal moves the information from the short-term to long-term memory. The example is when you try to memorize the vocabulary through repetition. But the AI system, the storage and the retention is by training adjust the model's weight to store information. The example is fine-tuning a model on specific data to enhance the performance, right? And the third is humans' retrieval of information. So the cues triggers the interval from the long-term memory. The example is when you smelling the perfume that reminds you some person. But the AI system is retrieval information by the queries that can access stored information in the databases or generate some responses based on the model's parameters. The example is you input prompts that guide this model to produce the relevant outputs. Let's talk about the detailed AI example which corresponding to human memory types. The first one is sensory memory as embeddings. So for example, the visual recognition. So AI processes an image of, let's say, a dog, which creating an embedding that captures features like shape and color. So this is very similar to iconic memory, where this image is briefly lingers the human mind, right? And the second is short-term memory as the context window in AI system. For example, the conversational continuity, which is during a chat, the AI remembers, oh, the previous user inputs within the context window. So if you say, tell me a joke, and then followed by now explain why it is funny, then this AI will use the short-term memory of reference to the joke. And the third one is long-term memory as external vector store. The example is knowledge retrieval. Is when AI uses a vector databases to find the relevant information when you ask some complex questions. The example is when you ask about the effect of the climate change, then this AI will retrieve and summarizes the scientific articles. And the final one is implicit memory as the model weights. The example is scale for text generation. So this AI generates the portrait or code base on the pattern that's learned during the training, right? For example, if you ask to writing a sonnet in the style of Shakespeare without any explicit programming for poetic structure. And then let's talk about limitations. So human memory has two limitations, which is decay and interference. The memory can fade or become distorted over time, right? And the second limitation is capacity constraints. That means the short-term memory is limited in duration and capacity. But the AI system also has two limitations, which is finite context window. That means this AI cannot process input beyond its maximum token limit in a single prompt. And the second limitation is this training data is cut off. The AI's knowledge is limited to some data it will train, which is up to some certain point. So how to enhance AI memory mechanisms? The first way is augmented long-term memory by integration with the external databases, just by connecting large language model to the live data sources for up-to-date information. The example is if you're using a plugin to access the current stock prices, right? And the second way is rehearsal and fine-tune by continual learning, just by updating the model parameters with some new data. The example is fine-tune the AIs on the current medical research to improve the diagnostics.